We've lifted the lid on the Android Studio box and pulled out Instant Run, a fast and shiny new emulator, a new GPU profiler, and all the new features and improvements of IntelliJ 15. I'm Reto Meijer, it's Android Tooltime time, and this is Android Studio 2.0. Instant Run is a new feature that, once enabled, lets you build and deploy incremental changes to your app within a few seconds, dramatically improving the speed of your test and debug cycles. Once you have your app up and running, hitting Instant Run after making code changes such as changing this chessboard from 2D to 3D and modifying the size and color of the pieces, will perform a hot swap, sending only the changed code to your app. The affected methods are overridden and your code changes are applied in real time within the running app instance. Hot swapping works by injecting code where you make changes. Your app isn't restarted, so memory allocations remain unchanged, meaning class initializers won't be rerun and static variables aren't initialized. Existing instances of constructs like fields and singletons are left untouched. Changing resources, such as editing colors, strings, or even layouts, will send the modified resources file to the running app, and you'll be able to see it when the activity is restarted, called a warm swap, which will do for you automatically if we detect that it's necessary. Some changes, such as modifying your manifest or changing layout IDs, currently trigger a full build. Exactly which changes will cause a full rebuild versus a cold or warm swap will change as Instant Run improves and evolves. So, rather than listing them here in detail and having this video become quickly outdated, you can find the details in the docs. Instant Run works with all emulators and every recent physical device, in fact, on every platform version all the way back to Ice Cream Sandwich. Not content with Instant Run, Android Studio 2.0 also improves each step of the full build and deploy process, so even full builds happen more than 2.5 times faster. The first time you hit run or debug for your code, or each time you do a clean build, your code is compiled and converted to DEX files, is optionally shrunk, optimized, and obfuscated with ProGuard, and has its classes and resources packaged all before it's uploaded to the device and installed. Android Studio 2.0 has improved each of these steps, starting with DX. We've reduced time here by over half, primarily through improving the DX merger algorithm. Now that merging DEX dependency modules is lightning fast, we gain significant gains from pre-dexing them and not redexing them if they haven't changed. So if your project has a lot of modules, you'll see significant gains here. We've also modified DX so that it now runs in process and you can specify running up to 4 DX instances in parallel. This has significant advantages as we no longer start a new VM for each DX instance, giving the JIT more opportunity to optimize code and removing the overhead of starting and running multiple parallel VM instances. If you're using ProGuard, it creates a single jar that effectively disables the pre-dexing advantages that we just gained. So we developed a new shrinker to use in debug builds. It doesn't replace ProGuard, it just replaces its shrinking functionality, so you'll still need to run ProGuard on release builds to optimize and obfuscate your code. But for debugging, the shrinker is much faster, by including some incremental support and critically by not redexing dependencies. To improve AAPT packaging times on full builds, we now ask you to select a deploy target before your app is built. We'll check what resources are required for that particular device. For example, initially we'll only package and push the appropriate image resource resolutions. And future Android Studio releases will expand that to include resources such as ABIs and legacy multidex. To improve deploy times, we improved the ADB push-pull protocol, making it very fast to deploy to an emulator, which seems like a really good reason to improve the emulator UX and make it really ridiculously fast. In fact, running the new emulator on typical dev hardware is faster than using a physical Android device. To achieve this, we've added SMP support to take advantage of host multi-core architecture and optimize GPU I/O and CPU performance. At the same time, we completely rebuilt the emulator UI. It now includes a toolbar to enable actions like screen rotation and screenshots, and support for deploying APKs through drag and drop. You can rescale the emulator frame by dragging a corner, modify device hardware changes like GPS, cellular network conditions, battery state, and incoming phone calls or texts. We've also made it easier to keep up to date. The IDE will prompt you when there's a new emulator available for you to download. If you're building something graphics intensive, like a game, you can take advantage of our new GPU profiler and debugger. It lets you record and replay the entire GPU stream frame by frame, allowing you to inspect the GPU state at each stage and help you understand what caused each specific rendering outcome. You can select an individual frame via either the top bar or the GPU commands panel. Once you select a frame, the frame buffer window will update to show that frame's contents. You can also see and inspect each individual command and GL call that was used. You can also use the GPU state window or the textures tab to explore GPU state at the time of your selected frame or draw calls. Android Studio 2.0 is built on IntelliJ 15, which offers improved stability and a number of new features, including improvements to the built-in integrations with version control systems, such as support for rebase on Git, and cool new features like find in path and distraction-free mode. There's also a unified user interface for testing that includes a test runner tool window, inline statistics, and a test result history. We've built on top of those test improvements, allowing you to have both Android and unit test source sets active while you develop, enabling refactorings across those source sets. We've also worked closely with Google Search to make it easier to create deep links within your app, including static code inspections to check that your links are correctly configured, and real-time testing to confirm Google can index and render your app pages correctly. In future episodes of Android Tool Time, we'll dive deeper into these and other new features from Android Studio. So subscribe to Android Developers on YouTube and check out the Android Tool Time playlist. And remember, if you've been taking your breaks based on building and deploying your app, you may want to start setting alarms to remind you to eat and drink at regular intervals. That's Android Studio 2.0, and this was Android Tool Time.